Okay, we're doing section 1-2, and the title of it is right here, Quadratic Equations. I thought I would throw this out at you real quick. Why in the world is it called quadratic? What is that word? You've probably heard it before. You've had Algebra 2, right? So why quadratic? What do you think, Justin?
Three variables?
Three?
It's four. Sorry.
You would think it would be 4, wouldn't you? Okay, and it kind of has something to do with 4, but and it does have something to do with 4, but it's not like 4 equations or anything like that. I'll show you this. It's Latin for this word right here. It's, try to write this a little bit better. I don't know how to really pronounce it. Quadratum or quadratum, probably quadratum, I would probably say. So that's Latin. That's Latin for square. All right, so the quad is 4, right? Let me do the talk. Let me do the talking. So quad is 4, and a square has what? 4 sides. All right, let me show you. And a lot of times when we find a square, we find the what of the square. That would be the area. So what would the area of this square be right here? One side is x, the other side, well, they're all sides are x because it's a square. So it'd be what? Be length times width, right? Which is x times x, which is what? X squared. So when you see an x squared, that's an indication that we're going to have a quadratic equation. Does that make sense? All right, so when you have an x squared, that means it's a quadratic equation, and that's where it comes from, in case you were never told. So I thought that was kind of interesting. I don't know if you did or not, but there it is. All right, let's talk about a quadratic equation. Let's write down what a quadratic equation is. So here is a quadratic equation. It's a very general form of a quadratic equation. And here it is. It's ax squared plus bx plus c. Now, if I just wrote that, is that an equation? Why is it not an equation? Because there's no equal sign. So we're going to put equals 0. So this thing right here is a quadratic equation. All right? So if you see something that looks similar to this, what's the A, B, and C? What does that mean? Does it mean it's always going to be A, B, and C? It stands for what? It stands for, it's variables, right? Okay, it stands for different numbers, okay? But you're always going to have the x squared in here and an x, and it equals 0, all right? If you see something that looks like this, this is a quadratic equation. You recognize that, right? Yeah. Right? You've had Algebra 2, correct? By the way, they call it the standard form of the quadratic equation. So sometimes they'll say, I don't know, sometimes they'll actually ask you to write something in the standard form of the quadratic equation. That's how you would do it. So let's go to an example. We all like doing the examples, right? So let's do example 1. So what you're going to do is you're going to solve for x on all these things. There's 2 parts to example 1. So this is part A. So it's going to be x squared plus 6x equals 0. Well, first of all, this doesn't exactly look like a quadratic equation because if I slide this up a little bit, what's missing on this one? Well, it looks like the A is missing. That's true. But what would the A actually be in this situation? It'd be a 1, wouldn't it? Okay. And what would the C be on this one? Is it? Yeah, it is. It's not because of this 0, but you're right. Matt, say it. Okay. But yeah, plus 0. That's what you're going to say. So technically it's this, isn't it? We're going to talk more about the A, B, and C a little bit later in the next section of section 1-2. But anyway, this is what we've got so far. All right, so the A would be 1, the B would be 6, and the C would be 0 in this situation. You good with that? I'm going to go back to the way I originally wrote it, like this. So what we're going to do here, this is kind of an easy form of a quadratic equation. This is one of the easiest forms of the quadratic equation. What we're going to do, and they ask you to solve. So what are you solving for here? It's pretty obvious. You're going to solve for 0. You're going to solve for x. You're going to solve for x, okay? So that's what we're trying to solve for. Now, this is a little bit different in the lesson that we did on 1-1 because we'd usually just have like 1x. We didn't have x squared. And when we did have x squared, what happened on those easy problems that we had in 1-1? When they actually canceled out, didn't they? Okay, they added up. Remember I said that? I was like, oh, this looks complicated because you got an x squared. But what did they always do? They always canceled out. They always subtracted from each other, right? In this situation, they're not going to do that. Justin, you got a question?
Oh no, I just gotta solve this.
Oh, okay. So what would you do? Justin, go ahead.
Well, you're trying to figure out what goes into 6 and what goes into 0.
Okay. So what do we call that? What's the word? We've used it. We've done a whole bunch of sections on that. It's one word, starts with an F. What's it called? Factor. Okay. So that's exactly what you were describing right there. Okay. So we're going to factor. So tell me, Justin, what does go into both of these?
Just 6 and 0, I believe.
6 divides into this evenly?
X.
And you're never going to say 0 divides into it because 0 can't divide into anything. Okay. But there is an x in common with everything here. Okay. So what you're going to do is you're going to factor out the common factor, right? Remember doing that, right? We had a whole lesson on it. So we're going to factor out the common factor. So if you factor out an x, what are you left with? If we remember what I said about factoring, you divide it out. So what happens right here when you divide out an x from an x squared? What are we left with? Just an x. Plus, always put that sign. And if you factor out an x or you divide this by x, what's left over? A 6. Okay? Now I'm going to show you something. Let's go off to the side over here. I'm going to show you something. We'll do this in a different color just so it doesn't blend in with this. We're going to talk about a thing called a zero. Oops, I thought I was going to blue. Where is it? There it is. Let's try that. Okay, now that should work. So I'm going to do a thing called a zero product property. Zero product property. I'll just put prop. That prop is for property, okay? So a zero product, what does that mean? That means when your product means it's an answer to a what kind of problem? Addition? Product is multiplication, okay? Product is the answer to a multiplication problem, okay? And so what we're doing is we're multiplying by 0, right? Or you're actually, I'm sorry, I shouldn't say you're multiplying by 0. You're getting a product that's actually equal to 0. Do we have a product over here that's equal to 0? Do we have something that's being multiplied that gives you 0? Sure, we have an x and an x plus 6. Let me show you this. What if I said, let's just use a regular number. What if I said 5 times blank, okay? We could put an x in there if you wanted to. I'll just put a blank, equals 0. So what do you think can go here? Is there many things that could go in here? Is there only one thing? Is there nothing that could go here? What do you think? No. No. An infinite amount of numbers. So there's all kinds of numbers in here. If I multiply it by 5, I'm going to get 0. I'll give you a hint. There's only one. There is only one number. It's 0, isn't it? Would you agree? Okay. So 0. 5 times 0 is 0. There's not an infinite. There's only one. There's only one answer that can go in for this. You with me on that so far? Okay, let me do something else. What if I said x times y is equal to 0? Tell me something about either x or either y or about both of them. What do you think, Aiden? One of them has to be 0. Would you agree? So if I multiply two things together and I get 0 as my answer, one of these has to be what? 0. Would you agree? Or not just one of them, but both of them could be 0. Would you agree? So I could say this. I could say x equals 0 and y could equal 0, right? You with me on this? All right. So either one of these could be 0. So it doesn't matter what x is. X could be like a 17. As long as y is 0, then this product is equal to 0. That's the zero product property. You with me on that? So with that said, let's go back to this. Go back to yellow. Look, I got two things that multiply together to be 0. So tell me something about this. This could be what? 0. Or this could be 0. Or both of them could be 0. Do you agree? So what I'm going to do, I'm going to set x equal to 0, and I'm going to set what? X. Remember, this whole thing is part of the product. So what am I going to write here? X plus 6 could be 0. You understand why we're doing this? This is a crazy important property, okay, that we're going to use over and over and over again throughout algebra. All right, so this is super important to understand. So one of these could be 0 or both of them could be 0. Everybody with me on that? Okay, so what we're going to do is we're going to actually solve for x. Well, we've already solved for x right here. X could equal 0, but x could equal something else. So let's just try this. Let's plug 0 in for the x up here to our original problem and see if it actually works. So what's 0 squared? It's 0. Plus 6 times 0 is what? 0. What's 0 plus 0? It's 0. I'm saying 0 a lot, aren't I? All right, so that works though, doesn't it? All right, so I did a little check, and so I can check that, and that definitely works. But there's something else that works that we could put in for this right here, and that would be what? Let's solve for x here. We can do that in our head without writing the step down, couldn't we? What's x equaling here? -6. So x could equal -6 as well. Let's plug that back into the original problem and see if it actually works. So let's put a -6 in for this. So -6 squared. So it's -6 times -6, which is what? 36. Let's put the -6 in for this x. 6 times -6 is -36. What's 36 minus 36? It's equal to 0. Does it check? Absolutely. So you get two answers. You get x equals 0, or you could say and x equals -6. You with me on that? It's not so hard to understand, is it? Okay, so when you have two things that are multiplied together and your answer is 0, any one of those things that's multiplied together could be 0, or both of them could be 0. All right? We're going to use that the rest of the time on this section. We good? All right. Let's do another one. Oh, I know what I was going to say. If you look in the back of the book, they don't write it like this. They don't write x equals 0, x equals -6. They write it as a set. Do you remember doing sets like this? So they'll actually put 0, comma, actually, I think they'll put -6 first because they put it in numerical order. So -6 comes before 0. So they'll put -6, comma, 0, and they'll close off the bracket like that. So this is how you'll see the answer in the back of the book. Am I going to make you write it like that? No. If you just want to write x equals 0, x equals -6, circle them both, that's fine with me. If you want to write it like this with the brackets, that's fine with me as well. And then just circle the bracket thing. All right? Either way you do that, I'm okay with that. All right. Now, that was basically the whole gist of that part of the lesson. So let's do another one. Let's do example B. This is example 1B. Let's do another one. It looks a little different, but it ends up kind of being the same thing. Equals x plus 3. Look at this. This really doesn't look like our quadratic equation, does it? I do have an x squared, though, right? I got an ax squared, and I do have a bx, and I do have a c. But what's the problem with this? It's what? It's in a weird order, and it's not equal to what? 0. Because when you write it as in the standard form of quadratic equation, you want to set it equal to 0. So let's do that. Let's change the order, and let's set it equal to 0. So let's put everything on the left-hand side, and then we'll put a 0 on the right-hand side. So let's do this. Let's keep the 2x squared right there. So what are we going to do with this x? We're going to move it over to the left. So what's that going to do for us? We should be able to do this in our head. How do we get rid of this x on the right-hand side? Subtract an x. Very good. So we subtract an x from both sides. That's going to give us a -x on the left side, correct? And then we do the same thing with the 3. Okay, move the 3 over to the left side. So we subtract a 3. And then we set it equal to 0 because we canceled these out, so what's left? A 0's left. Now it looks a little bit better, doesn't it? Now, nothing has a common factor, but we still are going to factor. This is why it's so important that we learn our factoring in that review lesson. So if you take a look at this, I'm not here to teach you factoring right now, so we're just going to actually factor it. So if you put some numbers in here, this is kind of like just guess and check kind of stuff, all right? So I'm going to put a 2x here and an x here. because 2x times x is 2x squared. And then you could try a couple numbers. You may not get it on the first shot, but this is what it is. Again, we've already taught factoring, so you're going to have to go back. If you don't understand why we did this, go back and review those lessons. All right, so this is factored. Would you agree? It's 2x squared. Let's do first, outside, inside, last. So first is 2x squared. The outside is positive 2x. The inside is negative 3x. So what's 2x minus 3x? Negative 1x. That works, doesn't it? And then the last term's negative 3 times positive 1 is negative 3. So it works. It is factored. But that's not what they're asking you to do. They're not asking you just to factor it. What are they asking you to do? And I didn't write it there. But all these say solve. Okay, we're going to solve for x. Now, what do we have? We have that same situation that we had in the first example. We have two things that are being multiplied together, and my answer is 0. So what are we going to do with those two things that are being multiplied together? We're going to set them both, what? Equal to 0. Very good. So we do that. So we set them both equal to 0, and then we go ahead and we solve for x. So I'm going to add a 3 to both sides on this one. I could just do this in my head, but I'll show you the steps. And then divide by 2. So that's one answer. X equals 3 over 2. Do you have to change that to a mixed number? Or yeah, to a mixed number? No, you don't have to. Remember I said back in middle school, teachers always made you do that, maybe even in Algebra 1. But you don't really have to in this situation. As long as it's reduced. Is it reduced? Yes. As long as it's reduced, it's fine. So I can use that as my answer. Let's do this. Let's solve for x here. That's pretty easy. So I subtract 1 from both sides, and I get x equals negative 1. And those are my two answers. If you wanted to take both of these, plug them back in, see if it works, feel free to do that. I'm not going to do that on every problem. But if you do have time, at the end of a quiz, at the end of a test, or even at your homework, doing your homeworks, go ahead and plug it in and see if the left side equals 0. If it doesn't, you either checked it wrong or you did the problem wrong. Okay, so that's how it goes. You could write it in the brackets in set notation. So what would go first? 3 halves and negative 1. Negative 1 would go here, and then 3 halves would go here. If you wrote it in set notation and put them in the wrong order, I'm not going to mark off for that. It's fine. Okay, but you could write it either way. To tell you the truth, if I was to do it, I would probably just put x equals, circle them both, and I'm done. Okay? But if you like that set notation look, feel free to do that. But that's the way it's going to look in the book. So when you look in the back of the book, it's going to look like that. We good? All right. Let's do another one. It's really not much different. Let's just go back to plain old white. So this is example 2. So here it is, and it says to solve. All these say to solve. This looks a little bit more complicated. All right. So the answer to this is a little bit different than what we just did, because before we got two unique answers. We'll talk about that in another section on what kind of problem gives you certain types of answers. But right now, we're just going to solve for x. So what in the world do? We don't have any common factor, but hopefully it factors. This is actually a perfect square. Do you remember perfect square factoring? Right? So if I take that 9 and that 1, multiply them together, I get 9, right? And if I take the square root of that, I get a 3, and I double it, and that gives me my middle term. That's how you can figure out if it's a perfect square or not. Again, we've done that lesson before, so let's just do it like this. You could put a square on the outside, but I'm going to do it like this. So it's actually 3x here and a 1 here, okay, and then a minus. So both of these are going to be the same exact thing. Again, this is factoring. I'm not going to take the whole time to go over, why it's this, but that's what it is when you factor. So now we're in that common situation that we just were talking about, the last two examples. So if I take this times this, it equals 0. So that means I'm going to set them both equal to 0. So I've got 3x minus 1 equal to 0, and I've got this one, 3x minus 1 equal to 0. and then we solve for x. But if you look at it, they're both exactly the same thing, aren't they? So do I have to really do them twice? Not really. So let's do this in our head. I'm going to add a 1 to both sides, and then I'm going to divide by 3. So that gives us 1 over 3. And this would give us 1 over 3 as well. If you wanted to do that, you could. Do you have to circle them both? Do you? This says x equals 1/3. This says x equals 1/3. Do we have to circle them both? Because they're not really two different answers. They're the same exact answer, right? So really, I could just circle one of them, and I'm finished with it. Now, if you circle both of them, would it be wrong? Of course not, okay? But you don't have to. X equals 1/3, that is your answer. If you wanted to take that, chuck it back into this to see if it works, feel free to do that. We're not going to do that right now. All right. Now, we have another little method to solve for these things, and this is called the square root method. So this is the problems are going to look kind of the same, but we're going to solve them a little bit differently. The square root method. Because in order to solve for it, we're going to take the square root. That's why they call it the square root method. So let's do an example. Well, this is kind of like a pre-example. We'll call it A. It's not even example 3. This is just how you do it. This is just very general. There's no numbers in here, but this is very, very general. So it's really not even an example. It's just to show you how to do the square root method. It's a P, and that's an equal sign. All right, so I've got x squared equals P. So what do I want to do? I want to solve. Now this time, on this one, I don't really know what I'm supposed to solve for, but we're going to solve for x, okay? So I want to get x by itself, but I got that squared there. I can't really factor that. So how in the world am I just going to get a square by itself when I have an x squared? Well, I'd like to get rid of that square root. I'm sorry, I just gave it away. I'm thinking ahead. I want to get rid of that square, so what do I got to do to it? I just gave it away. What do I do? Take the square root of it, okay? So in order to get rid of this square, I do the opposite. What's the opposite of squaring something? It's taking the square root. So I'm going to take the square root of both sides. But I'm going to show you something that we haven't really talked about. Again, let's go off to the side. I'm going to go different color here. Let's go off to the side and just give you a regular number. What if I said x squared equals 9? So what do? Take the square root of both sides, and then the square root of x squared is just x. What's the square root of 9? It's what? It's 3. But that's not my only answer, though. You're like, well, yeah, it is. I thought the square root of 9 is 3. If I put that in my calculator, if I put the square root of 9 in my calculator, I'm just going to get a 3. But there's actually another answer to this. 3 is one of the answers. But remember the original problem? If I take a number and square it and I get 9, so I could take 3, square it, and get 9. But what else could I square to get positive 9? A negative 3, couldn't I? If I take negative 3 and square that whole thing, I also get a positive 9. You see that? So I don't just get one answer. I don't just get a positive 3. I get a what? A positive and a negative. And that's how we show that. I didn't write that positive very nicely. It looks like this, a little bit bigger. We put a plus on the top and a minus on the bottom. That means plus or minus. That means you could get a positive 3 and you can get a negative 3. So when I take the square root of something, I'm always going to put a plus and a minus underneath of it because it's positive square root of 9, which is positive 3, or it's a negative square root of 9, which is a negative 3. You with me on that? So let's go back to this. So instead of just the square root of P, let me scooch that over, give me some room. So instead of just the square root of P, how am I going to write that? Plus or minus square root of P. You understand why I'm putting plus or minus? Because of this whole thing right here. All right, let's do one. Before we do a real example, let's do another one. And it's kind of what we just finished doing, but I'm going to put a 4 here. So if I was going to do this problem, what do? Take the square root of this, take the square root of this. But remember, when I take the square root, I'm going to get a positive and a negative version of it. So make sure you do that. You could put a plus minus here, but you don't have to. I'm just going to keep that square root the way it is. So the square root and the square cancel out, equals plus or minus what? What's the square root of 4? It's 2. And you can just leave it like this. If you wanted to, you wouldn't. You don't need to, but you could write it like x equals 2 and x equals negative 2. All right? If you wanted to write it like that, you could, but don't you like this a little bit better? A little more compact. You don't have to write as much. Okay, so I would probably prefer you write it like this. Now, I'll get in a second. The book, what do you think the book's going to do? Unfortunately, they don't put plus or minus 2. They write it in the set notation, and they put negative 2, comma 2. So this is the way the book is going to give you the answer. Okay, but I would prefer you write it like this. Okay, this is the way the book's going to give it to you, but you could just write it like that. Either way, if you write it negative 2, 2 in brackets, then that's fine. I'm okay with that. Or braces, they're not brackets. But anyway, you can do that. Yeah, Matt. That was the problem. Yep, that was the problem. That was just a very general problem. You could put anything in for P. So this is just the general method. This is actually sticking an actual number in for it. Okay. Now let's do a real example. It's not much different than we did, but I rigged those so they came out to a nice whole number. Not really a whole number, integer number, right? Positive 3, negative 3, positive 2, negative 2. So let's do a real example. So this is example 3. And again, it says to solve. Looks very similar to what we just finished doing. X squared equals 5. But this is not rigged so nice where it comes out to a nice integer answer, okay? So if you take a look at this, what do you think you're going to do? You got to get rid of that square, right? We're going to use that square root method that we just learned. So what are we going to do with those? Anybody? Just showed it to you. Square root, both sides. But if I take the square root, what do I need to put? Plus or minus, because you actually get two answers. If you just put the square root of 5, positive square root of 5, I'm going to have to mark it wrong because it's not complete. You have to give all the possible answers, okay? So that's going to give you x, and then you just write your answer, square root of 5, because I can't take the square root of 5 and get a nice even or integer number. So you just leave it like that. Pretty easy, isn't it? You're like, yeah, I wish they were all this easy. Let's do another one. Of course, they're not always going to look quite as easy. They're going to be a little bit different. So this one, they're going to extend it a little bit, make it a little bit tougher, but it's basically the same thing. Look at this one. Stuck a minus in here. What's up with that? Well, it only gives us one more step to do. So what's the first thing we do here? Get rid of what? The square. Okay, so how do we get rid of a square? Take the square root. Just to make it so it's not so sloppy, I'm not going to actually put the square root over on the left. I know it's going to go away, don't I? And then what do we get over here? Plus or minus. It's a weird looking square root. And what's that going to be? It's going to be plus or minus what? 4. Okay? And now what do we do? Got to get x by itself. So if I get x by itself, what do I have to get rid of? That minus 2. How do I get rid of a minus 2? I added 2. So I added to both sides. Now watch how I'm going to write this at first. I'm going to write 2 plus or minus 4. I'm not going to leave my answer like that because this will simplify. So I'm actually going to write it with two x's. X equals this, x equals that. So what is this? What is the first x? It's going to be 2 what? Well, let's do the top one first. Plus 4. It's going to be 2 plus 4. What's the other x going to be? It's going to be 2. Go ahead. Minus 4, right? You good on this? And so I got two answers. What's my first answer? X equals 6. It's 2 plus 4. And then x equals what? Negative 2. So those are my two answers. So I'm not going to write a plus or minus like I did here. Okay? It's just positive 6. It's not plus or minus 6. It's just positive 6, and it's just negative 2. Either one of these will work for this original problem that we had up there. Remember what the original problem was? Let's just do this in our head. Equals what? 16, right? That was our original problem. Let's see if it works. Let's put a 6 in for this. 6 minus 2 is 4. 4 squared is 16. Does 16 equal 16? Yep, it works. Let's try negative 2. Put a negative 2 in for this. Negative 2 minus 2 is negative 4. It's negative 4. Then if I square a negative 4 times negative 4, that gives us positive 16. So both of these work. Agreed? Don't just write positive 6 and leave it. I'm going to have to mark it wrong. I'm sorry, but that's incomplete. You got to give every possible answer. We good? And again, how's the book going to write it? What are they going to put first? Negative 2 and 6, and they're going to put it in these braces. They call these braces. So this is the way the book's going to write it, but I'm perfectly fine if you just circle x equals 6, x equals negative 2. We good? It's not so bad, is it? No, I like it. What color? Let's do that color. Check it out. We actually finished a little bit early today. Unbelievable. So here's some homework. I was nice and didn't give you homework over the weekend, so here's your homework. We're going to call it section 1-2, part 1. I think we're going to have 3 parts to this section, okay? So this is part 1, and it's pages 106, 107, and it's 9 to 33 odd. There it is. That's your homework. If you guys came in late and didn't get a, man, a lot of people came in late. If you didn't get a, what do you call it, lesson plan thing right here, come up and get it. I'm going to leave it up to you to pick it up. And that's on here. It's on the lesson plan thing, but now it's on YouTube. So if you lose your lesson plan thing, you could always go to RenWeb. You could always go to YouTube and find out what it was. Everybody good? All right, that's the end.